Okay, these are the second part to the notes for section 4.4 in unit 7. So we've already done the notes for exponential equations. Now I'm going to show you how to solve logarithmic equations. The techniques are the same way. I think some people are very intimidated by logarithmic and exponential equations, but they're not as bad. I don't think they're that bad. I think you just have to be very careful. So they're same as I did exponential equations. When I solved exponential equations, I showed you with the one-to-one property, and then I showed you with the inverse property. It's the same thing for logarithmic equations, and there's 4 steps for each. The one-to-one property is very easy, and it states if the log base b of m equals the log base b of n, then m has to equal n. Makes sense. They both have the same base. So just like I started out with exponents, the first example I don't have any work to do because it's a log base 2 equals a log base 2. So I don't have to isolate anything. I don't have to condense anything. So I can right away just write the terms equal to each other. So x plus 1 is going to equal 2x minus 5. If x plus 1 equals 2x minus 5, I solve for x. I like to keep my x's positive, so I'm going to subtract x from this side, and that gives you an x. I'm going to add 5 on both sides here, so I'm going to add 5 over here, and that gives me a 6. So I get x equals 6. And I'm going to check this the same way I did before. So 6 store x. Then I'm going to do log base 2 of x plus 1. I get a decimal. That's okay. I don't care what the decimal is. I just want to see if it's the same thing on the other side. Alpha window, log base 2 of 2x minus 5. It's the same decimal, so I did it correctly. The next example has a little bit more work with it. I don't have a logarithm equal a logarithm, so I have to do some manipulating. My directions tell you to condense the equation so a logarithm equals a logarithm. So when I condense this, I'm going to use the power rule. So I have log x cubed plus 5 equals log 24. Oops, I made a mistake. Log x cubed plus log 5 equals log 24. This is still not a logarithm equal a logarithm. I can condense these two. It's the product property. Since I'm adding these, I'm going to multiply. So x cubed multiplied by 5, I just like writing 5x cubed. I almost did it again. Equals log 24. Maybe that's why people think they're difficult. There's a lot of places to make little mistakes. You just have to be careful and check your work. Now I have a log equal a log. They're the same base. They're common logarithms. The base is 10. So now I just set 5x cubed equals 24. I'm going to divide by 5. And when I made this problem, I debated on whether I wanted to make it a nice, neat problem, and I didn't. I made it a hard problem. Well, not a hard problem. I made it to be very ugly. My answer is just going to be a decimal. I need to take the cube root of both sides. What I mean by that, I'm going to take the cube root here, and I'm going to take the cube root here. So it's going to get me x is equal to the cube root of 24 over 5. There's really nothing wrong with that answer, but mostly with exponents and logarithms, you're going to get a decimal answer. So I'm going to do the cube root. So I go to math, down to number 4, and I'm going to do 24 divided by 5. And I'm just going to get a decimal, and that's okay. And it's approximately equal to 1.687. Remember, we're going to 3 decimal places. I'm going to store that for x. I'm not storing the rounded. And I'm going to type in exactly what I had in this first line. So 3 log x, the calculator automatically put a parentheses there, so I have to end the parentheses, plus log 5. And I hit enter. And then I'm going to do log 24. It gets the same answer, so that is my answer. Typically, you don't do logarithmic equations on the SATs, but exponential equations are on the SATs, and they would expect you to do the one-to-one property without a calculator. So this inverse property is just like the inverse property for exponential equations. So I did the inverse property. If you had an exponential, you rewrote it as a logarithm, because exponents and logarithms are inverses of each other. So the same thing's going to happen here. But the first step is to isolate the logarithmic term. In this first case, my logarithmic term is already isolated, meaning I only have one log term, there's nothing being multiplied by the term, and there's nothing being added or subtracted. This minus 3 is not being subtracted from the log, it's part of the log. So now I can rewrite the logarithm as an exponent. So I'm going to write 4 squared equals x minus 3. Well, 4 squared is 16. Add 3, and I get x is equal to 19. And then I check it. I do check every single one of these problems. So I'm going to store 19 for x. And I'm going to type in log base 4 of x minus 3. And I got 2. So that's correct. The next one also is a fairly basic one. I'm going to leave doing the harder problems after you've practiced these for a little bit, where we have to rewrite them. And I'll do them in the live lessons. So this one is already isolated also, but I wanted to do an example with a base 10. So this is base 10, so I can rewrite this as an exponent. So I have 10 to the negative first power equals 2x plus 1. I see the 10 to the negative first power and I think, okay, well that's 1 over 10. You might not like that, but that's okay. You can use a decimal also. I prefer fractions myself. I'm going to subtract 1. So if you don't like fractions, grab a calculator. 1/10, and when I subtract 1, I get negative 9/10. Oops, you can't see it, the glare. Negative 9/10. So negative 9/10 equals 2x. I'm going to divide that by 2, and I get negative 9/20. I could leave that as a fraction. I could write it as a decimal. Same thing as negative 0.45. I prefer the fraction, but you don't. It does not matter. On a multiple choice test, which I don't do in this course, you'd have to be able to figure out which one is the correct answer you need, the fraction or the decimal. They wouldn't both be there. I almost forgot I want to check that. So I'm going to store that for x, and then I'm going to type in log 2x plus 1. And I got negative 1, so I did do that correct. These problems get a lot more involved, but these are good ones to start with for now. The live lessons, as we practice these, we'll do more and more complicated ones, and we'll see how far you guys are able to go with them. I want to push you a little bit, but I don't want to break you. But we'll go as far as you feel comfortable.